Hey everyone, in this video we're going to take a look at basic BGP peerings or neighbors, and we're going to take a look at how they differ in regards to um, advertising networks. So we're going to have three BGP ASs. The first one we're going to consider to be our corporate network. So we're basically going to say everything here in. This is all these routers 1 through 6 are all running OSPF. And we'll say that this is going to be network, we'll say 16 because it's routers 1 through 6. So this will be AS 16. We're going to have router 8, which is going to be an AS 8, router 7, which is going to be AS 7, and our corporate network, AS 16, is going to perform peering relationships with both of the routers, and these two are actually also going to perform a peering relationship. So we'll be able to see the difference in how OSPF works. And actually, for last step, we're going to take 5 and 6, and we're going to perform an iBGP peering here. So this will be eBGP, 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 and then iBGP. So let's go ahead and get these started. So the first thing we're going to do is let's just configure between routers 7 and 6. Let's configure that link. So we're going to go router BGP, and we are in AS7. Then we're going to do neighbor, and our neighbor is 10.0.67.6. The remote AS is going to be 16. Now let's take a look at our show IP BGP summary. All right, we can see we have the neighbor configured. We could see it's AS. It's OSPF, it's BGP version 4. It's up, down, never, and its state right now is idle. And we could see again, if we do it again, there's no change. So we have to go to R6. We are AS16. Our neighbor is 10.0.67.7, and it is in remote AS7. Show IP BGP summary. Okay, we're still down. Now we can see we're up, which it still says all zeros, but now it says we've been up for 6 seconds. We haven't received any prefixes, but we have a working neighbor relationship in BGP. So what I'm going to do is I'm going to simplify our diagram here so we can keep track as we go. So right now we have AS16 with a neighbor relationship to AS7. Now, we don't have any prefixes going across it, but let's just take a quick look at our neighbor relationship and see if we can see anything interesting. So BGP neighbors. So as you can see, this is a pretty verbose command. We could start here. We have our version 4, the remote router ID, the remote AS. We don't need to go over this now, but here's the capabilities exchange. Here's how many opens, messages were sent, so we could see, if we want to take a look at the different messages that we sent. The address family is IPv4 unicast, so that's the default. Anything else? No prefixes, so no sent, no received. No local policy denied prefixes, so we don't have a policy configured that's denying them. Anything else that we really want to look at? Not really. We have the neighbor relationship up. So let's take a look at injecting a route into BGP. So let's go ahead on 7 and show IP route. We have to have the route in the database. So we have a 7.7.7/32. So let's inject that route into BGP. Router BGP 7. Network 7777. This works a little bit differently than it does in OSPF and eIGRP. With here, we have to specify the mask, and it's not a wildcard mask. It's the actual mask of the network. So we have to put 255, 255, 2550, and it has to match exactly, or else it won't be injected into the BGP network. So it works a little bit differently. This is actually in advertising the networks. Where in OSPF and eIGRP, it was just sort of like an access list that would match the interface that we would put in the routing protocol. Here, we're actually advertising with the network command. So let's go back to R6 and let's do a show IP BGP summary. Now we can see here we have a prefix received. And if we do a show IP BGP, we can see what our network that we learned. So here's the network that we injected. Here's the next hop value, which is very important in BGP. And here are some path attributes. The thing that is important to notice now is the star and the bracket, which if we look here is valid and best. This means that we can reach the next hop. It's valid and it's best. So that's going to be the candidate that we put into our routing table. So let's go ahead and take a look at our routing table and see if that route is in there. Show IP route BGP. And sure enough, we have the code of B, which stands for BGP. And that's it. So that's how we can inject the route into an eBGP peering. Now, what we're going to do is let's take a look at two things. We'll quickly establish a BGP relationship here, which is also going to be eBGP. So let's first do that. So let's go to R7 and let's do conf t router BGP 7. And we're going to do neighbor is 78008 with a remote AS of 8. And then let's do conf t router BGP 8. Remote AS of 7. Show IP BGP summary. It should come up in a moment. Now we're up and we're learning a prefix. So show IP route BGP. Show IP BGP. Okay, we're learning it. We have the next hop of 67. Okay. So let's take a look at what's going on here. So usually when we get a valid but not best, that's because the next hop is not reachable. But in our case, ping 78007, the next hop certainly is. So that, just wanted to show you, BGP is slow by default. We can't tune it. But now we can see that we're valid and best and we're running. So let's do this. Let's take a route from 6 and let's inject it into BGP and see if R8 will learn it through R7. So conf t router BGP 16 network. Okay, so let's head over to R7, see if we're learning the route. Show IP BGP, and we are. We have valid and best. R8, valid and best. So we can see through 2 eBGP peers that we're learning the route. I'll just draw it. We're learning the route of 6's loopback, which goes to R7, and then R7 advertises it to R8. So now let's do something different. Now let's take a iBGP peering. So we're going to do iBGP between 6 and 5. And let's see if the route learned from 7 to 6, let's see if it makes its way over to 5. So what we'll do is quickly just on R6, conft router BGP 16. Now in iBGP peering, it's different, but it's configured exactly the same. So we do neighbor 10.0.56. Well, it's actually, you know what? We could configure it with directly connected, but let me show you a different command. Because it's iBGP and we have multiple ways to get there. So say, for example, we can get there over this link, but if this link here, let me, let's do green. We can get there over this link, but if this link goes down, we would want the neighbor to still be up over this link. And the way we would accomplish that is by peering them through loopbacks. So I know I said this was basic peerings, but this isn't too complicated. You could do the peering neighbor 10.0.56.5, and then remote AS is 16. So it's just the same AS. You could do the peer that way, but let's do a little bit different. Let's do our neighbor is going to be 5.5.5.5, and the remote AS is us. Now, if we go to 5, neighbor 6.6.6.6, remote AS is also 16. We can see the neighbor is there, but it's not coming up, which is weird because we should have a route. We do have a route, and on 6, do show IP route. This is because it's not technically directly connected. So what's happening is that we're sending it out through our link of probably 10.0.56.0, and that's the source of the packet. So R5 hears the packet coming in from that source and says, well, that's not the neighbor that I'm configured for. I'm configured for 6.6.6.6. So what we have to do is we configure the neighbor 5.5.5.5. Our update source is our loopback. And let's go to R5 and configure the same thing. conft router BGP 16, neighbor 6.6. Update source is loopback 0. Now we can see we're up. So that's the update source command. Not exactly basic peering, but also not too complicated. Show IP BGP summary. Okay, so now from R6's perspective, let me get rid of that. We know we were looking at this route here from 7. So let's do R6, show IP BGP. We have the route from 7. Let's see if it advertises it to 5. Show IP route, or show IP BGP, excuse me. And it looks like we do. So we are learning it from 10.0.67.7 as the next hop. That's a little bit different, but we are still learning it. So at least we know that the an eBGP to an iBGP will still learn the route. But let's take a look at this next hop. And actually, you know what? The video is about 15 minutes. I'm going to hit pause or hit stop, and I'll create a new video about the next hop processing. So I'll upload it immediately after this one.